Okay, we're going to go through trying to figure out if something is quadratic regression or linear regression. We're going to use a calculator for this. We're going to plot it and look at it, and we're also going to look at how good the data fits the linear models and quadratic models. Alright, first thing I want you to do, make sure you have your calculator out, and we are going to turn it on and clear it. So first thing you need to do, second plus 712, enter, done. We're going to look at this first set of data. I want my calculator to do most of the work for us. So the best we have to do is remember our steps. We're going to put this information in there. Top number is L1, bottom number is L2, X and Y. So go to Stat, Edit, and we're going to plug all those in order. 84, enter. 76, enter. 79, enter. 88, enter. 95, enter. 82, enter. 87, enter. 88, enter. 75, enter. 82, enter. There's all my X's. Now my Y's, my L2, my outputs. 12, 22, 25, 15, 11, 19, 13, 18, 20, 22. Alright, what I want to do with this first is I want to plot it on the graph. If you go look at the graph right now, of course nothing's there. We have to turn the scatter plot on. So we're going to do a stat plot. So where it says stat plot in blue above y equals, we're going to touch the blue button and then that button. Plot 1, L1 and L2, it is off. So we're going to go ahead, press enter, and we're going to turn that on. That's all you got to do. Now we're going to go back and we're going to hit graph. Didn't really do much for us. This window only goes from negative 10 to positive 10. Negative 10, positive 10, negative 10, positive 10. None of these values are graphed in there. What I like to do is go to Zoom and go down to number 9 where it says Zoom Stat. All this stuff is being done in the stat. Might as well go Zoom Stat. Press enter and look at that. It sets the window for us where it shows us all of our scatter plot points. First thing we're going to do, we're going to look at this. Do we think it's linear or quadratic? I look at it and I'm like, I'm pretty sure that's linear. If I put this pencil down like that, that's about what my trend line will look like. So I'm going to go out on a limb right now without looking at the numbers and saying this is linear. That's going to be the best way to represent this data. But if I look at it too, I can also make a little bit of an argument to say maybe this is quadratic. If I look from here to here, I can kind of see where I might have a U-shaped quadratic formula. So we're going to do a linear regression and a quadratic regression, and we're going to see which one is better. I'm going to record how strong they are, my linear and my quadratic, see how strong they are. So let's go back to the stat and calculate. First thing we're going to do is linear regression. One thing we have to do that I just almost forgot to do is we have to turn our diagnostic on to get our R values to see how strong they are. We use the catalog down here for that. So blue catalog, and we go all the way down to diagnostics on. Press enter. Make sure you have the little done on there. If you have not gotten it done, you have not finished it. Alright, now we can go back to stat, calculate. We are going to do a linear regression. You don't have to do this, but I'm going to show it. You don't have to do it, but I'm going to show it. You can store that in Y1. So I'm going to go here to store regression equation. I'm going to press the vars key. And the vars, I can go to yvars and function, and I can say I want this in Y1. What that says is we're going to store this equation we get in Y1. I'm going to go ahead and calculate it. So my linear regression, my R value is 0.76. So there is a 70% chance that it is good data, 70% solid. So we have not great, but we have some sort of correlation for linear. If I look at my graph now, that is the line we got. I'm not going to write the graph, the actual equation down. It's not my goal right now, but that's what it would look like if we graphed it. And again, that looks just like that, putting the pencil across here like I did earlier. Now let's do a quadratic regression. So same thing, go to calc, but instead of going to linear regression, we go to quadratic regression. Press enter. I'm going to do the same thing here. I'm going to store it, vars, yvars function, and I'm going to put it in y2 so I can have both at the same time. To read this, we read it slightly different. There's my equation is ax squared plus bx plus c. This is my a value, this is my b value, this is my c value. You can tell these numbers aren't great. And my r value here we look at r squared. R squared is 0.58. So it looks like my linear is the stronger of the two. We actually have linear correlation at 0.58. The quadratic relationship is, I'm not going to say it's not there, but it's not, definitely not very strong at all. So that by far this is more linear than quadratic. And as you look at this quadratic, I guess it's coming from like this very wide arc, wide U like this. Okay, let's look at another example. Let's skip to one that I know is quadratic. Area and radius. So we're going to look how strong linear it is and how strong quadratic it is. So let's go ahead and put this new data in the graphing calculator. I'm going to go to y and I'm going to clear all these equations out. Clear, and then stat enter, and plug all these in. To clear these, by the way, go up there and press clear enter. Go up there, press clear enter, and plug all these in. 1, 2, 3, 4, 5, 6, 7, 8. Over. We have 3 enter, 10 enter, 28 enter, 50 enter, 78 enter, 113 enter, 154 enter, 198 enter. Those are all my points. So let's first look and see what they look like. I've hit my graph. I don't really see anything. What I want to do is zoom stat again. Zoom stat. I can definitely see from this data that there is a curve. So more than likely this is going to be quadratic. The other thing I do want you to notice is it's also pretty linear. So there is going to be some sort of linear correlation. It just may not be the best. But we can definitely tell that this is going to be a U-shaped parabola. You have to think though it's over here. It spreads out. We're seeing half of it basically. Alright, stat. Calculate. Let's do the linear first. Go through. I'm going to store these in there so we can see it. Press the vars key, y vars over, down to function, y1. Okay, here's my equation. I'm not going to worry about getting the actual equation right now. But my r value is 0.97, 0.98 if we round it. That's a very strong linear correlation. This linear thing will predict the future points very, very well. But now let's look at my quadratic. Go down to quadratic regression, press enter, and let's go ahead and store this in there. Vars, y vars function, put this in y2. If I look at this now, here are my a, b, and c values for my equation a, b, and c. Here's my r2, which is 0.999, which is basically 1. This is almost perfectly perfect. So this is by far, even though this other one's 0.98, this is by far a better representation of the data. This is the one we want to use. The number is much closer to 1. So let's go ahead and look at the graph now. There's my linear trend line. You can see where it covers most of the data. But now look at my quadratic trend line. Do you see how it is much closer to all the points? That's why it is a better representation of the data. Let's look at one more. Let's go ahead and go back to the months problem I skipped a second ago. It says for us to use the months, the input year, sorry, the number of the month as the input. 2, 4, 6, 8, 10, 12 are my months. So we're going to predict temperatures that way. I'm going to do this one fairly quickly. Sorry if I go a little quick. We're going to do, first we're going to clear this out of y equals, clear, clear, and now we can go to our data, clear my data, clear my data, and over here we have 2, 4, 6, 8, 10, 12, and my temperatures are 52, 72, 84, 86, 71, 52. Let's look at linear and quadratic. First thing let's go ahead and graph them. Zoom stat will show us all of it. Zoom stat will show us all of it. And I can very clearly see that this is going to be a quadratic representation of data. The best model is going to be a quadratic model for this. But I'm going to go ahead, again, I know it's quadratic, I'll put a star by quadratic. I'm still going to test linear and then the quadratic as well. So my linear stat calc, linear, I'm going to go ahead and store it. Not 10. Bars, y bars, function, y1. Alright, my R value is negative 0.004. That is basically as close as you're going to get to 0 as possible. So we know that's definitely out of the equation. But I'm going to put it in there just because, prove point in a little bit. Alright, next one, stat. Calculate quadratic regression, y vars, function. We're going to put this in y2. And here we have a 0.99. That means this is very, very quadratic. It will match the data very well. So let's go ahead and look at the trend lines. I'm going to go back to my graph. There is my linear trend line. If you notice, if it cuts straight across left to right, that's virtually no correlation. It has basically a slope of 0. That's what it's going to look like if there's no correlation. See how it doesn't really come close to matching the dots at all? But then my quadratic matches very closely. And that's it for this.